Hello, everybody. We are here together on this JRC4 Biodiversity, Forestry and Agroecology seminar of UNIgreen, the Green European University. Today with me is Hélia Marchante. I hope I pronounce your name well. Thanks. And we are here to listen more about Trichilogaster. It's a gall wasp that we'll learn more about in a couple of minutes, I hope, because I know absolutely nothing about this species. So I'm thrilled to listen about it. So today's seminar will look as follows. We will start with Hélia's speech. Then we will follow this by a discussion afterwards. All of you will be able to ask us a question using the Q&A button on the top of your screen. So you can ask questions directly there, or if there will be any technical troubles, we'll be able to give you the right to speak. But in order to keep this communication smooth and not have any problems with the video calls and internet bandwidth, we are keeping this video and voice to a minimum for now. And after the discussion, I'll have a small announcement about new seminar, and we'll conclude the meeting for today. And Hélia is our partner from Polytechnic University of Coimbra from Portugal. She's a biologist, so I will not introduce her anymore. I'll leave it to her to tell us some short words about herself, and then we can proceed for the seminar.
Thank you for the invitation and for my presentation. Good afternoon to everybody. I work at the Escola Superior Agrária in the Polytechnic University. And well, since I finished biology many years ago, I've started working with invasive alien plants. But today I will be speaking about one of the key subjects that I work, which are of course related with invasive alien plants, but it's more specific. It's about biological control of invasive alien plants, and I'm going to share with you the story of the biocontrol agents that we work for a longer time now. Okay, so I will share my screen, and the name of the biocontrol agent that I'm going to share with you, it's Trichilogaster acaciaelongifoliae. And it's an insect. It's a small gall wasp that we imported from the South Hemisphere to control acaciaelongifoliae, long-lived wattle, okay? And I'm going, my name is Hélia, I'm here, but I'm going to present the work of many people. So I have 10 years of Trichilogaster, but in fact, we have now the 11th year. And we have many people along the way that worked with us and that still work with us. And this project, this long-lived project, would not be possible without all these people and more. And basically, I am going to tell the story of how we change this plant, acaciaelongifoliae, with these bright yellow flowers, with the help of this insect, this gall wasp, into this. And without the flowers, we don't have the seeds, okay? So just a very, very brief introduction, because I guess not all of you eventually are aware of biological invasions. So invasive alien species, all the invasive alien species, not only the plants, are a global problem. And in 2023, there was a global report made by IPBES that made an evaluation, an assessment of what was the condition of this huge threat to biodiversity globally. And they reached many conclusions, but I will just briefly share 3 of the most key conclusions of this report. And it says that basically, invasive alien species are responsible for the extinction or they contribute to the extinction of over 60% of the species that are nowadays being extinct. And the invasive species do not do this alone. Many times they do this with other threats, but they are involved in over 60% of the species extinction at global level. And this is huge, okay? It's very frequent to speak about the other biodiversity threats of global changes, of pollution, but sometimes we forget to speak about invasive species, and they are in the top 5 of these threats. Then there is also a huge economic value associated, a negative value of costs associated with these species, not only about the things that we are losing because of these species, but also about the money that we have to expend, to waste, to manage these species, and it's huge. And then the key conclusion of this report is that 85% of the impacts on nature, but also on our quality of life, are negative. And this means, of course, that if it's 85% and not 100%, it means that there are some positive, the other 15 are positive effects that we have to acknowledge and to consider, and sometimes they are responsible for some discussions, okay? And I will not go deeper, but you have here the link if you want to access the report. It's a fantastic report with lots of information. And then if we try to come to a more focused context, in Portugal and in the European Union before, we have a regulation, this regulation that creates a list of invasive alien species that are species of union concern. And according to this regulation, each member state has its own regulation. And in Portugal, we have this decree law that has its own national list of invasive alien species. And they are many, okay? They have plants, animals, algae, many different taxonomical groups, but I will only speak about one plant, okay? And this is the plant that I'm going to speak today. It's one among many, over 100 species that we have in this Portuguese national list of invasive species, and it's acaciaelongifoliae. And so to present it, it's many times it's just a shrub, but sometimes it grows to be a small tree. It produces used to produce these yellow flowers in spikes, and it came from Australia many years ago, and it was introduced to sand stabilization, so to stop the erosion of the sand next to the ocean. And in that earlier times, we are not aware of the problems that it may cause. But then, mostly after fire events, but also after other disturbance events like storms, cuttings, any kind of thing that disturbs the soil, it starts spreading, and it is now much wide distributed than it used to be the original sites where it was planted. It invades, this picture shows stand of acacia. It almost only have acaciaelongifoliae, these dense stands that replaces species and habitats, and it doesn't do it only in Portugal. It also does it in several other countries, and then some of them are here, but mostly in areas with Mediterranean climate. The key points for this species to be invasive is that it has a huge production of seeds. These seeds are long-lived, that they can live for several decades, buried in the soil, and they accumulate to huge numbers. You have some of the soil samples that we have quantified with over 16,000 seeds per square meter, but sometimes we found in other areas even higher number of seeds. And this means that when you disturb the vegetation somehow, these seeds that are buried in soil are stimulated to germinate and to reinvade very, very quickly. In a different way from other acacia species that we also have, other acacia species as invaders, this particular species, acaciaelongifoliae, it's not a strong resprouter. So the seeds really make the invasion possible, and the species do not resprout as much as other species. And so just to have an idea, the seeds germinate, give these tiny seedlings, but then they quickly become a dense stand, completely covering everything. When we start working with these species, we start measuring the impacts of the plant in communities, in plant communities, in insects, in soil, in the very, very different areas, and it has negative impacts at these different levels. And we have it quantified, so it's very concrete. And then we start thinking that with the methods that we were using, mostly physical methods or chemical methods, we were not achieving success. And we should search for alternatives. Alternatives that can be more sustainable and from both ecological and economic point of view, but also that gives some more results at long term and not only soon after the cuttings. And when we made this reflection, we consider classical biological control. So classical biological control is basically to go to the native region of the weed, of the invasive plant, search for natural enemies, and then select the natural enemies that are very specific and are not able to affect other species, make many tests, make risk assessments, like really know, to try to see everything that this new agent can do in the new environment, test it, ask permissions, and then release it. And when we think about this in Europe, back in 2015, when we released this Trichilogaster, there were only 2 agents against invasive alien plants. There are many agents against invasive animals, mostly invasive insects, but not against invasive plants. And this is different from other parts of the world. If you go to Australia, South Africa, North America, Canada, there are many agents released against invasive alien plants, but not in Europe, okay? In old times, there were some agents in Eastern Europe. But in 2015, when we released Trichilogaster, there was only this Aphallara itadori in UK that was released 5 years before. And there was also this fungi against Sympacium glandulifera released 1 year before. And then there were a few agents that were released like in the 60s or earlier than that, mostly in Eastern Europe, but also one in Madeira. And then in 2015, we have released Trichilogaster acaciaelongifoliae against acaciaelongifoliae. And then after that, there was new releases in UK and also in the Netherlands against Crassula elmesi, and more recently, this agent against Hydrocotyl ranunculoides, an aquatic invasive plant. So this is basically the story of the agents against invasive alien plants in Europe, which is very different from other regions of the world, as I said, where biocontrol is much more common against invasive alien. let's know a bit about Trichilogaster. Trichilogaster is this very tiny wasp. This is very big because this is only when the wasp has like 2-3 millimeters. It's from Australia, and it basically lays the eggs in these tiny buds of the plant. When it lays the eggs, the plant reacts and creates these galls, and then the insect develops inside the galls until from all these phases and until he reaches the adult phase, these galls, and get out of the gall and search for buds again. So it's a very sad story. So he just stays inside these galls for most of the year, and then in 2 days it get out of the gall and die. Put the legs, lay the eggs, and dies. And this happened. This agent was introduced before in South Africa over 30 years ago. And when it was introduced in South Africa, it was tested in over 40 plants. In Portugal, we tested over 40 non-target species to see if the agent, if the insect was able to create these galls in any other species, but it wasn't, okay? And then, so it's very, very specific. In Australia and in South Africa, it also lay eggs in these 2 plants, Acacia melanoxylon and Parasianthus lofanta, which are 2 mimosoidea, so they are very closely related with Acacia longifolia. But in Portugal, we also have these 2 species as invasive species as well. But we have always searched for galls in these species, and until now we didn't find any. Okay. Anyway, in Australia and in South Africa, they are very sporadic. So the agent stays for most of the days of his life cycle inside the galls. Then it emerges, but most of the individuals are females. So it is a parthenogenic species, which has it doesn't need the males. And in fact, in some populations, we only have females, and they search for the flower buds, mostly for the flower buds, but if the plant has some tiny vegetative buds, it also can lay the eggs on them, and it produces these galls, okay? So basically the galls develop instead of the flowers. Without flowers, we do not have the pods that the plant normally produces. And without the pods, we don't have the seeds. And without seeds, we don't have the capacity of the species to spread as much as it used to be before the agent was introduced. I'm not going through these carefully, don't worry. Just to give you an idea that the process to introduce it since 2003, when we first considered it, until release was a very long. It was a process that took over 12 years, and the agent was already selected because it was available, it was on use in South Africa, but it went through many tests and risk analysis at national level, at European level, and then finally 12 years later, and after many tests and careful analysis, we got the permission to release it. And what do we expect? We expect that at short term, it will reduce the seed production and the dispersal of the seeds. If there is no seeds, there are no seeds to disperse. And it will, of course, reduce the number of seeds that enter the soil seed bank. Then at the long term, we hope that the reduction of the germination will occur. That will take for sure more time, because the seeds that are already buried in the seed bank will be there and will be alive. So unless we have some fire or other disturbances that make the seeds to germinate, we have to count that they will be there for long, because the agent is not able to affect the seeds that are already in the soil. But in the long term, we hope that without new seeds entering every year, this will also reduce. Then we know that when the plants are with some kind of physiological stress, for instance, if they are water stressed, the plants, and if they have many galls, that they can die. So it's not expected that plants die because they have galls of Trichilogaster, but when plants are stressed, some plants will eventually die with many galls. We are very committed to evaluate the establishment of the agent and to understand where it is reproducing, where it is decreasing, how much it is decreasing the seeds, how it's affecting the target plant, is it having any effect on the non-target plant? And now I will share with you some of these monitoring that we have been accomplishing since 2015. And we made a full country assessment in 2023. All these dots, these full dots, are places where the establishment is confirmed. But when we do it more recently, we can see that all the green quadrats are confirmed presence of Trichilogaster. So acaciaelongifoliae is a coastal species, as I said before, and the agent, of course, is overlapping the distribution of the plant. And the places with red, some of them, they don't even have acaciaelongifoliae, so of course they cannot have the target, the galls. But it's present nowadays from the south to the north in most of the areas where acaciaelongifoliae is present. We did have some challenge because when the agent crossed the hemispheres from South Africa to Portugal, it was not in the same phase, same phenological phase as the plant. So it needed this very tiny buds to lay the eggs. But when it reached Portugal, back in December of 2015, the wattles had big buds. And so it was not easy to synchronize the life cycle of the agent with the life cycle of the plant. And the establishment in the first years was quite slow, and it increased very slowly. But after 2018, we already had enough galls in Portugal to release in new places the galls that we have here. So we do not have to import them from the South Hemisphere. And that made a huge difference. And after 2018, the agent started spreading much more quickly because it was already synchronized with the target plant, with the long-lived wattle. Then we have measured what the agent is doing in the plant, in the target plant. We measure it in many different aspects. But one of the most impressive values is that we have a reduction of the seeds that in some places is over 95% of reduction of the seeds. So it's really reducing the output, the reproductive output of the invasive plant. But we also have measured the growth of the branches and the number of phyllodes and the number of pods. So, and there is almost in all situations a reduction, but the number of seeds was the one with higher reduction. So it's really making this job well. Then it's also reducing the growth of the plant, and so to make them less healthy, if we can say like that. In some occasional situations, we got what we expect as rare, but we are getting some plants that they have so many galls that they are dying, and mostly when the plants were already stressed somehow. So it's possible to see nowadays some acacia that are just dying with many galls. when we measured the seeds, the parameters associated with the seeds, we see that the sweet drain is really decreasing. So in these bars, you can see that this is the number of years since the establishment in several places. And after this third, fourth year, there is a huge decrease of the seeds that are produced. And in some places, the seeds with the galls don't have any seed produced. So it's really reducing the seeds very much. But when we look to the seed bank, so not to the seeds that are produced every year, but to the seeds that are buried in the soil, the results are still growing. So the seed bank, what we can see is that the seed bank is not growing anymore. So because there are no new seeds each year. And we are seeing that in the litter, in some of the places, the seeds on the litter are already decreasing, but in some other places, the seeds are just stabilizing, so they are not growing anymore, but the ones that were there before are still there. And even in soil, so under the litter, in the soil, there are some signs of stabilization. So the absence of addiction of seeds every year, it's already stabilizing the seed bank. And this can be more, have more results if we integrate this agent, this biocontrol agent, with other strategies that will remove the seeds from the seed bank. So we can have, like, for instance, some mechanical removal that will stimulate the seeds to germinate and to get out of the seed bank, or controlled fire, or something that we integrate with biocontrol agents and helps to decrease the seeds buried in soil will be very valuable. And we have also evaluated this measurement of the integration, and it's really positive. We have also studied the life cycle of the agent. Because of this change of hemispheres, the agent in the earlier times was not synchronized with the life cycle of the target plant, but now after 6 years, it's already completely synchronized, and that's why he's spreading more in these more recent years. And we have, of course, made a very strong effort to measure if there is any impact on the non-target plants, because this is one of the things that people are more afraid about biocontrol agents, about introducing new agents, new species to a new place, is if it has any effect on the non-target species. And we have measured over 70 species and non-target species, and until now we have zero, so a huge zero values of galls in any of the other species that we measured. So of course, that was what the tests in quarantine environment predicted, but of course that we have also always to check it on nature, and it's very good for us to confirm that it's not doing anything on the other species, on the other plant species. But we went further and we tried to see on the ecological networks level, so not only on the non-target plants, but also on the other gallers that are available in the ecosystems. So we have measured in any of the other plants that have galls if the agent is somehow interacting. And we have seen that we do have some inquilines, so other insects that use the gall as a house. But until now, we have not confirmed any parasitoid that may be harming the gall wasp. And that's also very good for us. And on the opposite side, the presence of this galler is decreasing the impact of the invasive plant in the systems, and that's very positive. So we are analyzing not only directly the non-target plants, but also at the ecological level, all the other species that may be interacting with this red. This red, it's always Trichilogaster, the plant, acaciaelongifoliae and Trichilogaster in the system, and you can see that it doesn't have interactions. And we have also tried to analyze it at a more remote sensing approach to see if we are able to measure in a more quick and efficient way the decrease of the flowers of the species and interpret that as a proxy of the presence of the gall wasp. We are still moving. We don't have the best results that we would like to have until now, but we have now a new project starting to improve this. So to try to detect the agent, the goals of the agent in a more larger scale. But we are able to see the reduction of these flowers, not the goals per se. And then we have made a huge effort to raise public awareness about biological control, because it's a new approach in Portugal, in Europe, the biological control of invasive alien plants. And so people are very suspicious, sometimes are against, sometimes they do not know what it is. And so we decided from the beginning to raise public awareness, to engage technicians, the common citizens, to try to raise awareness about this biocontrol technology. And we think nowadays it's more common for people to understand what are these new structures that are appearing in nature. And we have also become fans of citizen science. So we have a project, we have citizen science projects with the plants per se, with the invasive plants, but we have created a project on iNaturalist that it's called Trichilogaster, acaciaelongifoliae, in the Iberian Peninsula. And we are basically asking citizens to take a picture of the acaciaelongifoliae that you see with these goals and just put it on the map. And this map, this establishment map of Trichilogaster along the coast, we have a huge, fantastic collaboration of many citizens around the country that are giving their pictures and their locations. We have also another approach. It's a more demanding one with a more complete protocol. It's not so much used as iNaturalist, it's EpiCollect, but it collects more data, and for us it's very important. And I invite you all to use it if you are here in Portugal. To finish, so there are some take-home messages. We are very positive and encouraged by our results so far. We have learned a lot about this system, about the way a new species introduced in this ecosystem is working and how it's interacting with the target plants and all the system. We have learned a lot. Also with the ecological networks approach and the biocontrol per se. Trichilogaster is really well established along the coast, and it is really doing its job well. So it's really decreasing very significantly the seeds produced every year. And it's true that it's not affecting it, but it was not expected to affect the seed bank buried in soil, but the results are accumulating. And the most important, without negative effects on non-target species, and that's, of course, very important. We have concluded, we have realized that the management needs to integrate not only biological control, but also other methods, mostly in this particular case with this agent to help reduce the seeds that are in the soil. And it can be done successfully, but it has always to guarantee an integrated approach to be sure that the other methods are not destroying, eliminating the biocontrol agents populations, because otherwise, when the seeds germinate, they will not have the insects to control the production of the seeds. So they have to be carefully integrated, and the other methods cannot destroy the agent. Citizen science is being a huge help, and it's helping to increase a lot the amount of data that we have about the locations of the gall wasp across the coast. And it's really fantastic to have citizens working with us. But we need to get faster and scalable monitoring tools. And so this new project, the Rescue Project, is a project that started in the end of 2025. And we are, of course, keeping the monitoring of the agent at several levels, but we will also want to develop, to improve the remote sensing capacity to monitor, to help it monitor in a more scalable way. And increasing public awareness. I believe that today I'm also doing this to try to increase public awareness about this biological control is essential to Europe, to Portugal, but also to Europe, because we really need to use more classical biological control to get a chance to manage more properly the species that we have spreading a lot. And so we have applied to a cost action about biocontrol, and we are now waiting for the results. To finish, I will just very briefly go through other agents that we are starting to work with. So Trichilogaster, it's our agent for ages, but now we are improving its detection and rescue project. We are collaborating with other partners to get agents to other acacia species, and we are also searching for funds to get the chance to start working with water invasive plants, water hyacinth, elodias, ludwighias, but these are in the next in line. And we are searching, we are not actively searching, but we are finding agents that were introduced accidentally as far as we know. But when we are in field, we realize that there is a natural enemy from Azolla, that it's present in many countries in Europe, and in Portugal we have confirmed its presence. We also have found some natural enemies that nobody introduced, as far as you know, against Ailanthus, against Cortaderia celuana, and so sometimes the natural enemies are just introduced accidentally because they came with the plants probably, and we are trying to analyze their situations. Okay, and that's all. I'd like to thank you all for listening, and now I have to thank to all these amazing team that has worked with us for many years now, and some new ones, and that's it.
Thank you, Hélia, for this really interesting talk. For sure, you got my awareness for the topic, because, yeah, I think that every country has its own invasive plants, or every region, let's say, and they are fighting them in a different way. So I will have some questions for you in a moment, but maybe I'll remind everybody how we are working now. So we will start the discussion. You have the Q&A button on the top of your screen, so you can ask questions there. I'll try to monitor them and see what questions are waiting to be asked, because I will read them aloud. But before you start asking them, or maybe our audience needs some time to think, so maybe I have some, for sure I have some questions that maybe you can answer. So
Okay.
as I started, that every region has its own species, its own problems. And I also remember from my visit to Portugal that there were multiple species of acacia, some of them more aggressive, let's say, the others maybe not so far. So then my question would be, as you know, we always talk about this example of rabbits in Australia and the problem that they brought. And so let me rephrase what you just said. So we use a species from different part of the world to fight another species from a different part of the world. So we are fighting the problems we made ourselves, right? Of course, not us, but generally people. So my first question would be, why did acacia was chosen in the first place? So I know that you have for sure some problems with the ocean shores, but for example, here we were using also alien species for us, which is Pinus nigra, which for you might be more local. So here it's said that Pinus nigra is a very good species that will stabilize sandy dunes. And you mentioned in the beginning that you used acacia for this purpose. Can you just give us some hints, like why people do this? Do they suspect there will be some problems, or they are so optimistic that we can overcome them if we bring new
I guess
species?
for many centuries now, we start moving species from one location to another. When we search for a solution for a problem, I guess nowadays we are starting to have a different approach, but for many time we search the solutions somewhere else. So we have native species that we can use to sand binding. The most curious is that, for instance, one of our best species to sand stabilization is Ammophila, which the New Zealanders and the Californians when come here and take that species to sand binding their sands, their dunes, but we didn't use it. We just went and searched the solution outside. And I guess we have done that very often. So we just think that, I don't know, I'm not in the head of people that made that choices, but for many times we think that the solution has to be something that it's outside. But we do it by that time. Of course, we cannot blame because there was not the knowledge that species can behave differently. But the main question, I guess, is that by that time the species were introduced without testing if they can behave differently. And with the biocontrol, that's the most important difference. When we search for a species to try to control the species that is behaving as invasive, before we even consider to release it, we make a full range of assessments, tests in quarantine environment to prevent the introduction of species that can have effects that we don't want. And for instance, the example of the rabbits in Australia, it's very famous. It's a very bad example that went very wrongly. But when it was done, the tests that were supposed to be done very rigorous were not done the best way. And that's why it was wrong.
Yeah.
But it was done many years ago, okay? So the knowledge that we have today was not available by that time. So we have to put it on the right historical context. But the question, the most important difference between moving species to find solutions, many different solutions, sand binding, wood production, as ornamentals. We use species, exotic species, for many different reasons. The questions when we use them as biocontrol agents is that we really test them, and the methods to test them nowadays are very demanding, very rigorous, to try to bring species that can have non-target effects. But and it's also very important to distinguish the idea of introducing a species. It's an exotic species that comes to a new territory, and it's most of the species, they just stay in the place where we put them, and there is a small fraction, a small percentage of all the exotic species that then becomes invasive and creates problems. And so when we are working with the biocontrol agents, all the tests is to try to prevent that the species that we are introducing will fall in that invasive species percentage, and they will stay with the exotic species that are not having the unwanted results.
Yeah, we always see the problematic ones, right, as they emerge. In the meantime, I'm encouraging all our participants to maybe ask some questions. Maybe something was interesting that you would like our speaker, Hélia, to talk more about. And in the meantime, because when you mentioned that we are thinking that the answer to our problems lies someplace else, we have a saying here in Poland that, you know, a grass in our neighbor's garden is always greener. We always believe that something which is not here will be better, but probably it's not. I mean, maybe not that much as we think of it. And when you mentioned that you have been testing this for 12 years, which is a lot, I have an example of a species that we've been using here. Pinus banksiana was introduced in Poland, I don't know, in the 70s probably, or 60s, because for very poor soils, it was believed to give us a good amount of wood that we needed at that time. And it was growing very, very, very good for the first 2 decades. And then it was slowing down a lot compared to our species. So, for example, now we are having probably last testing after 50 years from the establishment of a sample plot, that we are seeing that it's not growing anything good compared to local species, but it had to, you know, we had to see it after 20 years to know it. Before that, we were sure it was going to be great. So sometimes even, you know, from our perspective, 20 years is long term. From the forest perspective, we all know it's nothing very long. So it's good that we are more restrictive right now, that we think more about what we are doing, because those rabbits, I know they are extreme example, but people know the extremes well, so they remember them. So this is one thing. And I had one more question about this. You said it's a very monospecific species, that you tested other species. Typically, you found in this table that there were 0 plants that were invaded by Trichilogaster. But for example, on the contrary, we have here some insects. One of them is Ips typographus, so a bark beetle, and a very well-known, widespread Białowieża forest problem, that the bark beetle was typically a spruce species. But you know, all the insects, they are having those patterns, so those infestation that sometimes they occur every 4 or 7 years, or whatever the pattern is. And so we found out that moment that the bark beetle was attacking also pine trees, which was not happening any time before. But because there was no food and there were enormous amounts of the beetle in the air, they were just attacking anything, sometimes even sitting on the deciduous trees when they were not, you know, not the same class. So, but of course they could not, they were not damaging it, but still they were trying. So my question would be how you think it might end up with this species, because I know you are testing it for more than 10 years, but have you seen any patterns in the emergence of the insect?
One thing with this agent is that, as any other gall wasp, it can change. Insects are living beings. They can change with time, and we cannot predict that fully and 100%. Sure. But the question with gall wasps, or with gallers in general, is that if their change is not enough. For instance, when we made the quarantine tests in very confined environment, we basically confine the insects with the non-target plants for their whole life cycle as insects. So the wasps emerge from the galls, and the only thing that we give them for their whole life was the non-target species. And in that stressful situation, it was not able to produce galls in any other species, but it was able to lay eggs in 2 other species. The question is that with gallers, it's an evolutionary process from many millions of years, where not only the galler has to choose the plant, but the plant has to react to the eggs that the galler lays.
In a specific way, right?
In a very specific way, because the agent, for instance, we got in quarantine in this very limiting process where when the wasp was alive, we confined it with only the non-target species to test. It was not able to produce the galls, but it was able to lay eggs on vitis, on wine species. The eggs were not in the proper position. They were like outside the bud, but it laid the egg there. So it was full of eggs. It was all its life in contact with a strange plant, and it laid the eggs. The question is that the plant was not able to interpret that and to create the gall. And I guess with gallers, that's why gallers are so good biocontrol agents, because it's not only per se, it's also the reaction of the plant when the gallers lay the eggs. And the other plants are not prepared to create the eggs, because they only have developed this. There are many, many plants with galls. We don't see it because we are not trained to see them, but there are many, many plants with galls, but they only react to that egg. So it's like it's a fantastic co-evolutionary process. And we think it prevents it's even more difficult that some change in the future will produce a non-target effect, because of this need of the 2 species have to be synchronized to produce the difference. But of course, one of the things, we have tested the species, but then there were risk assessments at national level and at European level, and they tried to analyze the big picture with the results. And one thing that it was very valued is that we have measured very well, to quantify it very well, the impacts that invasive plant is producing. And so we don't have only to think if there's a risk. Of course, that even if it's a reduced risk, there will be a risk that the agent can change and have any other effects. But the question is, we are having too much effects with the invasive plant with the current methods. So we need to fight it back, because we have to create a balance between all the negative effects. And the biocontrol agents, even if it has some risks, it will help to decrease all the damage that the plant is doing. And that's because it's kind of very different. It's really very different in Europe and in Australia or New Zealand or South Africa or Canada or United States, where they use biocontrol for longer, with some very bad examples in earlier times mostly. But the question is that they are reaching with several species, several invasive species, more success in managing them, in reducing the impacts that they are doing more successfully than we are doing in Europe. And so I guess we have.
Let's hope we won't have to fight agent with another agent.
No, I mean, we can. There is a very interesting, it's a bad example, but it's interesting. We have an invasive plant that it's Opuntia, a cactus species, and it was introduced, I'm not sure how, we believe it was accidentally, a cochineal, that is it is used in some countries as a biocontrol agent. It was used, it appeared in south of Spain accidentally. There is no record of any tests or any introduction, but the Opuntia is appreciated by growers that grow the figs. And so now some people is working in biocontrol agents to the natural enemy that was introduced accidentally.
Okay.
But normally it doesn't happen. It's
Okay,
very
thank you.
particular.
Thank you for this explanation. I don't see much any questions for the Q&A, so and seeing the time, we should slowly finish this seminar. So I'll just have one small announcement before we finish. So each time we are showing you also, oh, it's not opening right, so just give me a second, because each time we are finishing a seminar, we are also showing our audience an option for the next seminar. We are finishing this Trichilogaster seminar by Hélia Marchante, and we are going for the next one, which will be run by Anna Sofia Fajardo about integrating electrochemical technologies into advanced and sustainable water treatment. So I'm inviting all of you to join us on the 19th of May. It will also be a Tuesday at this time at 12 at noon of Central European time on Microsoft Teams. We'll also distribute the invitations through UNIgreen website and all our channels that we have for this, so you'll be informed about it. And for today, it was very lovely to listen more about Trichilogaster. Thank you, Hélia, for your wonderful speech. I really enjoyed it a lot because these topics are totally new for me. So I'm learning a lot. I hope that our audience also enjoyed it. And I hope to see you all on our next seminar next month. Thank you. Have a good day. And bye-bye.
Bye.